Hello everyone, welcome to another topic on quant. And if you are for the first time in this channel, then hi, I'm Orko. What we do here is talk about quant topics that are relevant for your CAT, INMAT, SNAP, IFT kind of exam, basically covering all India-based MBA entrance exams. We also do DILR, but right now we are doing a series of algebra. So the last session was on logarithm. Today we are going to talk about another very important topic for your algebra is progression. So in progression, we will typically focus on two things: AP or arithmetic progression and GP or geometric progression. Now, some of you may have done AP, GP in your school days, but this will be a refresher. And some of you who have not liked it or avoided or did not do AP, GP also in your school days, this will be a start from scratch, and absolutely you can master this. There is not I will not say this is a very complex thing that you can't grasp. So even if you have a not so nice experience working with or solving a PGP problem in the past, or if you are seeing this for the first time also, absolutely fine. We will go in such a way that you can understand from the very basics. And like we always do, we cover every topic in three sessions. The first session being the fundamental. So today we are going to talk about the fundamentals, and the follow-up two sessions will do the problems. The first problem session will be focused on the conceptual problems or level one, some level two kind of problem that will help you cement your understanding in APGP formulas and how we use them, when to use what formula kind of a scenario. And then we will deep dive on the level 2, level 3 kind of a problem in the last problem session, where we do advanced or little complex level problems on APGP. So those two problem sessions will come after this video. So this video is absolutely focused on your fundamentals of APGP and absolutely understanding it from the scratch. So that's where we will focus this time on. So let's move on. So what we do and first starts with AP, or like I said, it's a arithmetic progression. Okay. Now, what do I mean by arithmetic progression? Let's say you have a set of numbers and not any set of random set of number. Let's say the numbers looks like, let's say 2, 5, 7, 9, 11, right? Like this. Let's say then you have another set of number. Let's say 2 plus root 2. I'm just trying to make it a little different. 2 plus root 2 plus 2 plus 2 root 2, then 2 plus 3 root 2, something like that. So you have, let's say, these two type of number. Now, if you see, there is a pattern in both the series of numbers. So let's say this is series 1, series 2. In the first series of number, if I do 5 minus 2 is 3. If I do 7 minus 5, sorry, let's start with 3. So 5 minus 3, it's 2. 7 minus 5, it's 2. 9 minus 7, it's 2. So you see all the difference. So here the difference is 2, here the difference is 2, here the difference is 2, 2. So always the difference is kind of same. So can I say difference between two consecutive number will be same. Okay, the difference between two consecutive number are same in the first scenario. Let's see in the second scenario what we have. We have 2 plus 2 root 2 at the second number minus 2 plus root 2. So my difference is root 2. Same if you do 2 plus 3 root 2, that is the third number. If you subtract from the second number, you will also get root 2. So again, the difference is kind of same. So this still valids. So the difference between two consecutive number, when it is same, it may not be positive always, or it may not be an increasing series. It may be decreasing. So the same series I can write as 11, 9, 7, 5, 3, 1. So in this case also, the difference between two consecutive number is same. It may be plus 2, it may be minus 2, that's separate. But the core fundamental of a series is an arithmetic progression is only possible when the difference between two consecutive numbers remains same, right? Now, if I take any random example, let's say 1, 4, 10, 13, obviously the number difference between two consecutive numbers are not same across the series. So obviously that number we can't say, that series we can't say in an arithmetic progression or any progression as per matter. So to satisfy the condition of arithmetic progression, the only criteria is difference between two consecutive number has to be same, right? Now, if this is understood, now let's see if a series is, let's say 2, 4, 6, 8, 10. So let's say these are the 5 number series, and it is an AP because the difference between all the 5 numbers between their consecutive numbers are 2, which is same, right? So if I say my first term here is 2, what is my second term? This is 2 plus the difference. Now this difference is also called as common difference. Since the difference is always same, this difference is also called as common difference or CD. So let's say this is common difference. So if I add the common difference or CD 2 with 2, what I'll get? 2 plus 2, that is 4. What is my third term? If I start with 2, I multiply 2 times of common difference, that I'll get 2 plus 2 into 2 or 6. What is my fourth term? Fourth term. So 2, that is my first term, plus 3 times my common difference. So that is 2 plus 3 into 2 or 8. So what I'm trying to say is I can find the nth term by putting the first number or the first term plus n minus 1 into common difference. So very, very important understanding how to find the nth term of an AP. So for example, let's say you have a series 1, 5, 9, 13, 15, and someone asks you, can you tell me what is the 13th term in this series, right? So I can see this is AP because all the gaps are equal to 4. So my common difference is equal to 4 here. Now 13th term, or I can say T13, T is representing the term, is the first term. First term here is 1 plus n minus 1. Now I'm looking for 13th term. So my n is 13 here. So 13 minus 1 into 4. So 1 plus 12 into 4. So 1 plus 12 into 4 or 49. So this is my 13th term in this series. If you go ahead and keep adding 4, you will see the 13th term is 49. Now, so in a common way, so Tn or nth term, we'll say is A plus n minus 1 into D. So this is a very important formula where Tn is your nth term, A is your first term, and D is your common difference or CD. So this is a very, very important formula you need to remember. So Tn is A plus n minus 1 into D. So this is one time. So you have to find out what is the nth term of our FP. Okay. Now, if this is clear, please let me know in the comment section if some part is not clear. So we are trying to find out formulas and that we can use. So this is a very important formula where we are trying to find out the nth term of a series of an AP. So Tn, which is the nth term, is first term plus n minus 1 into common difference, the way we did it in the previous problem, this problem I mean. Okay, let's move to the next part. Now, the other one is sum of nth term. That is another common thing that has been asked. So let's say the same example, 1, 5, 9, 11, 13. They are asking you, find sum of first 13 terms. So basically what you have to do, 1 plus 5 plus 9 plus 13. So I know the 13th term from the previous problem is 49. Till 49, I have to do a sum of this. Is there a formula that can give me right away rather than doing all the sums? This is what they are looking for. When I say sum of first 13 term, that means 1, 5, 9, 13 till 49, sum of everything. Is there a better way? Let's see. Let's say Sn is the sum of first n term. Now I can say A1 plus A2, A1 being the first term, A2 being the second term, A3 till I can say AN. AN is the last term, nth term. Now can I say A1, A2 is what? If I go back to this formula, A2 is what? In here, A2, or I can say A2 is nothing but term 2. Term 2 will be what? A plus 2 minus 1 into D, or I can say A plus D. Right? If I apply this formula, so same way, if I go back and do here, A2 will be what? A plus 2 minus 1 into D. What is A3? A1 plus D. A3 will be A1 plus 3 minus 1 into D. What will be A4? A4 will be A1 plus 4 minus 1 into D. So instead of A3, I'm writing it like this. Instead of A2, I'm writing it like this. Okay. So then what will be my nth term? My nth term will be A1 plus n minus 1 into D. Understood? Okay. Now, if I see, then there are n terms, means there will be n times of A1, because for first term there is a A1, for second term there is one A1, for third term there will be another A1. So n times of A1, n times of first term, plus first term is D, second term is 2D, third term is 3D, and then finally you go to n minus 1 into D. Right? So if I do that, this is n into A1, D common, 1 plus 2 plus 3 dot 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 n minus 1. Right? Okay, so till now it is understood. We did n into A1 plus D to 1 plus 2 plus 3 till n minus 1. Now if I write it again, so Sn is n into A1 plus D into 1 plus 2 plus 3 till n minus 1. Now here you need to remember one basic formula that I'll tell you. Let's say there is a term which is also an AP, 1 plus 2 plus 3 dot till nth term, where the common difference is 1. This is commonly introduced into n plus 1. This is one formula to remember. N into n plus 1 by 2. When you have 1 plus 2 plus 3 till n. So this is a standard formula. You can take with any example. So let's say 1 plus 2 plus 3, there are 3 terms. So if you have 3 terms, let's say 1 plus 2 plus 3 is what? 6. Now, if there are 3 values, then you can do 3 into, in this formula wise, 3 into 3 plus 1 by 2, or this also will become 6. So this is the same. So here there are not n terms, but there are n minus 1 terms. So n in this formula will be replaced by n minus 1. So then we will do n into A1 plus D into, first is n minus 1, which is equivalent to this n. Then you have n plus 1. So n minus 1 plus 1 by 2. So we'll say n A1 plus D into n minus 1 into n by 2. So if I take n by 2 common, it will be 2a1 plus n minus 1 into d, right? So this is the formula of Sn. So sum of nth term is n by 2 into first term plus n minus 1 into d, right? So what we learned, Sn is n by 2 into 2a1 plus n minus 1 into d. Okay. Okay. So what we're trying to say is, so this is another formula you should be remembering. So there are two formulas then. What we learned is first is sum of n terms. Sum of n terms is Sn equal to n by 2, 2a plus n minus 1 into d, and nth term is equal to Tn what was that? A plus n minus 1 into d. So if you see, this is what we did. Tn, a plus n minus 1 into d, and the same thing here. So these are the two main formulas of your arithmetic progression, right? So where we know a is the first term and d is the common difference, right? So these are the two things you just need to remember from d. Now you also see there are certain derivations or certain other formulas which is derived from this. Let's say if I know Sn is equal to n by 2, 2a plus n minus 1 into d, I can write this as n by 2. If I break the 2a into a plus n minus 1 into d, this part is basically the nth term, and this is the first term. So can I say n by 2 into first plus last term? So this is also an important formula you can remember, which is sum of n terms can also be written as first plus last term into n by 2. Okay, so that way also you can write it. Now the other thing you can see is, let's say there are 5 terms, let's say 1, 3, 5, 7, 9. These are the 5 terms, so they are in AP because the common difference is same in all the cases, it's all 2, right? Now normally what I can say, the sum of n terms or sum of the 5 term here n is 5, so I'll write Sn is same as S5 is 5 by 2, 2 into 1, that is the first term, plus n minus 1, n is 5 here, so 5 minus 1 into d, common difference is 2. So this is coming as 5 by 2, 2 plus 8, 10. So 5 by 2 into 10, or 25. So if you do 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16, 16 plus 9, 25. This is 25. The other way also we can do S5 is 5 by 2, the first term plus the last term. So 5 by 2 into 10, which is 25. So both the ways you get the same answer. Other important observation here is, if you see this series 1, 3, 5, 7, 9, can I say first term and the last term? So T1 plus T5 here, which is the 5th term, is same as T2 plus T4. T2 plus T4 is same as 2 times of 3, which is the middle term. Right? So in a bigger series, if you understand this, let's say A1, A2, A3, or for example, for easy, let's say term 1, term 2, term 3 till Tn. In this AP, if these are in AP, then I can say T1 plus Tn is same equal to T2 plus Tn minus 1 is same equal to T3 plus Tn minus 2, and so on, right? If n is odd, then sum of n terms, which is Sn, can also be written as n into middle term, right? This is another one you can remember. So let's take the same example in the past. 1, 3, 5, 7, 9. What was the sum? It was 25. That was the sum. By using this formula, we can say S5 is equal to 5 terms, and 5 is the middle term because 2 terms on the left, 2 terms on the right. So 5 into 5, 25. So you can see this is also another formula. So these are the overall things you need to understand from a AP standpoint. So basically, what we are focusing on here is, this is the main 2 important formula. This is one another formula you can remember. Again, derived from this formula only. So this is the main base formula. And then you can also remember this sum of n terms is n into the middle term. And the other one, this is very important. First term plus last term, second term plus second last term, third term plus third last term, all those sums are individually equal. Okay. So this is the one. Okay. So these are the 3-4 things we learned from AP. Now, the last 2 things that we want to focus on AP. If we say 3 terms are in AP, the classic assumption to do that is A minus D, A, and A plus D. These are the 3 terms you can assume. If the numbers are not given, then you can assume this. If they say 5 terms are in AP, then your assumption should be A minus 2D, A minus D, A plus D, A plus 2D. So these are the 5 terms. When they say 5 terms are in AP and the numbers are not given, you can assume it like this. The final thing, this is how you to assume the number. Let's say there are 5 numbers, 1, 3, 5, 7, 9, our classic example. This is in AP. Now, if I add 1 to all of them, that means this become 2, 4, 6, 8, 10, which is still in AP. Now, if I multiply 2 with all these numbers, so what it will become? 2, 6, 10, 14, 18. That is also in AP because the gap now is 4 every cases. So if you see, same operation in all terms, result still in AP. So if I do the same operation by adding same number, by multiplying with same number, by dividing with same number, if I do divide with 2, all this number, first one become 0.5, second one 1.5, third one 2.5, fourth one 3.5. So everywhere there is a gap of 1. So if I do same operation on all the terms, the resultant series is also in AP. Okay, so this is also a good understanding or good concept to be learned. So there are a few concepts that you need to learn, and I will say there are 2 base formulas And then there are a few concepts that we are covering. Okay. Now, let's move on. The next topic is on GP, or geometric progression. Okay. So GP or geometric progression. So AP, we see the common differences are same. What are the things in GP? Say 2, 4, 8, 16, 32. Let's say these are the 5 terms. Now the differences between are not same. But if I see 4 by 2 is 2, 8 by 4 is 2, 16 by 8 is 2, 32 by 16 is also 2. So what I say, the ratio of 2 successive term is same. This ratio is also known as common ratio and commonly denoted as R. Okay, so AP, we know the differences has to be same, and GP, we know the ratio has to be same. Ratio of 2 successive term has to be same. So you can do 4 by 2 or you can do 2 by 4, whatever you do. If you do 2 by 4, this 2 will become half. Then 4 by 8, half. 8 by 16, half. 16 by 32, half. So all the ratios has to be same if it has to be in GP. So the only condition of AP is the ratio, the differences has to be same. The only condition for GP is the ratios has to be same. Okay. So let's say the first term. Say the first term is 2. What is the second term? Second term is 2 into the common ratio, or if I had the values 2, 4, 8, 16, 32, 2 into 2. So this is 4. What is my third term? It's still the first term into 2 common ratio square, or I can say 2 into 2 square, or 8. What is the fourth term? First term into common ratio cube, or I can say 2 into 2 cube, or 16. So what I can say, my nth term in GP is Tn is equal to A, which is the first term in our example, which is 2, A into R to the power n minus 1. So this is the first formula of GP, right? Sum of nth term, and I can show the derivation, but let's not dive into the derivation too much because you don't need to derive that. So sum of nth term, we can say is in A into R to the power n minus 1 by R minus 1. Okay, this is what we want to do. This is or we can say A into 1 minus R to the power n by 1 minus R. Okay, so these are the two formulas. So basically this is when R is greater than 1. This is when R is less than 1. So these are the two formulas you can use when R is greater than 1, when R is less than 1. It's R to the power n minus 1 by R minus 1 in the first place, 1 minus R to the power n by 1 minus R in the second case. Okay, so these are the two main formula. But if you see this, you can use both of them interchangeably. It does not take much, but this is normal practice to use when R greater than 1, the first one, and R less than 1 is the second one. The other two things we wanted to cover quickly in terms of GP. But one, if they say 3 terms in GP, then your normal assumption is number, first term A by R, second A, third AR. 5 terms in GP, the normal assumption is A by R square, A by R, A, AR, AR square. So these are the ways you can assume when the numbers are not given. Just say 3 terms are in GP, 5 terms are in GP. This should be your starting point, and then apply whatever the condition given in the problem. The last part of infinite GP series. So why we did not do infinite AP series? Because AP series, if you add, this is just addition. So obviously the difference is always same. So there is the sum is always infinite. Let's say I have 2, 4, 6, 8 till infinite terms. My sum will also be infinite. Similarly, if R is greater than 1 in a GP series, let's say your GP series is 2, 4, 8, 16, 32, like this, then also this is an increasing GP. So the sum of all this number will be always infinite because 2, 4, 8, 6, the last number is infinite. But if R is less than 1, let's say your GP is 1, 1 by 2, 1 by 4, 1 by 8. So basically till infinite. So in this case, what is your R? R is half by 1 or half. So if this is infinite, then you see the values are slowly diminishing. As we go to infinite, the values tends to 0. So there is a possibility to get a sum. Let's see how we can do it. So then your Sn will become A into 1 minus R to the power n, and we'll use this because my R is less than 1 now, by 1 minus R. Now, as n, no, sorry, as n increases, R to the power n keeps decreasing, because let's say, what is my R here? Half. Now, half to the power 1 is 0.5. Half square is 0.25. Half cube, or 1 by 8, which is 0.125. So see, the values are decreasing. So as and when n increases, R to the power n typically decreases. And if n goes towards infinity, R to the power n also goes toward 0. So for n, when n is infinity, because we are talking about infinite terms, so my R to the power n will tend to become 0. So this will become A into 1 minus 0 by 1 minus R, or A by 1 minus R. So we can say sum of infinite terms is A by 1 minus R when R is less than 1. This is also a very important formula in GP. A lot of problem you see asking for infinite terms, but remember, when your R is more than 1, you can't find the sum. It's anyway infinite, like in AP. But if R is less than 1, there is a possibility to calculate the value, and the value is A by 1 minus R. But understand why R to the power n becomes 0 when n is infinite. Because if R is less than 1, the more higher power you raise it, it will keep getting lower and lower and lower. And towards when the power is high enough to become infinite, it's almost 0. So R to the power n is infinite here. R to the power n basically becomes 0 when n is infinite. So this is what we want to cover in APGP, some of the basic formulas, some of the basic nuances of APGP. And with this much understanding, don't need to digress on the formula or fundamentals level beyond this. We will use some of the problems in the next session, where we will cement these understandings very well. But before that, go through it, try some of the basic problems, level 1 problems from your textbook or anywhere you get some of the initial problems. You can try it at home. We will come back in the next session and we will cover from the starting level problems, not very complicated. Some of the problems will use this formula. We'll see how to apply these formulas in a given problem set, and from there we'll take off to the complex level problem in the third video of this series, APGP. Okay, so hope you have a good one. See you next time. Thank you.